Good morning to all. I am Dr.B.Angelin, Assistant Professor, Department of Information Technology, working in Dr. S.N.S. Rajalakshmi College of Arts and Science. Now I am going to discuss about process synchronization in operating system. These are my table of contents. What is the process synchronization and why it is needed? The critical section problem, Peterson solution, synchronization hardware, semaphores, applications of semaphores, classical problems of synchronization, synchronization examples such as a monitors, atomic and transactions. What is a process synchronization? Several processes run in an operating system. Some of them share resources due to which problems like data inconsistency may arise. For example, one process changing the data in a memory location where another process is trying to read the data from the same memory location. It is possible that the data read by the second process will be erroneous. Process synchronization. Producer consumer problem to ensure that the producer should not add a data when the buffer is full and the consumer should not take a data when the buffer is empty. For buffer producers, consumers. What is a process synchronization? Solution producer consumer problem using semaphores. Semaphore is a variable or a abstract data type that is used for controlling access by multiple processes to a common resources in a concurrent system, such as a multi-programming operation system using a monitors and atomic transactions. Monitors. In concurrent programming, a monitor is a synchronization construct that allows threads to have a both mutual exclusion and the ability to wait for a certain condition to become a true. Atomic transaction. Atomic ready modify write access to share variables is avoided as each of the two count variables is updated only by a single thread. Also, these variables stay incremented all the time. The relation remains correct when their values wrap around on integer overflow. Race condition. T5 happened before T4. A section of code common to n cooperating process in which the process may be accessing common variable. A critical section environment contains entry section codes requesting entry into the critical section. Critical section code in which only one process can execute at any one time. Exit section, the end of the critical section, releasing or allowing other in. Remainder sections, rest of the code after the critical section. Critical section problem. The critical section must enforce all three of the following rules. Mutual exclusion. No more than one process can execute in its critical section at one time. Next one is progress. If no one is the critical section and someone wants in, then those processes not in their remainder section must be able to decide in a infinite time who should go in. Bounded wait. All requesters must eventually be let into the critical section. Critical section problems. Section, critical section, exit section, remainder section. Peterson solution. To handle the problem of critical section, Peterson gave an algorithms with a bounded awaiting. Suppose there are n processes and each of them at some point need to enter the critical section. A flag array of size n is maintained which is by default false, and whenever a process needs to enter the critical section, it has to set its flag. There is another variable called turn which indicates the process's numbers which is currently to enter into the computer system. The process that enters into the computer system while existing could change the turn to another number from among the list of ready processes. Synchronization hardware. The problem of critical sections are also solvable by hardware. Uniprocessor system disable interrupts while a process PI is using the computer system, but it is a great disadvantages in multiprocessor system. Some systems provide a lock functionality where a process acquires a lock while entering the computer system and release the lock after relieving it. Mutex locks. The synchronization hardware solution is not easy to implement for everyone. A strict software approach called a mutex locks was introduced. Thank you.